guys. So, yep, we have plenty of participants. Myself, I'm Vishwa Vardhan. So, I'm working from India and I did my B.Tech. There is some college like NIT Kerala, and I did Masters in Structural Engineering that we call M.Tech here from IIT Madras. And yes, I'm working as tutor here in Bhavanam C2C. I will be taking the structural engineering subjects and one fluid mechanics. Yeah, that's all about me. And so you guys, anyone want to ask anything else?
What about your job?
I'm working as a project manager, deputy project manager in India for a firm.
And Vishwa, I've been attending your classes like a
Mm.
month back, like 1.5 month back.
Mm-hmm.
Your way of explanation and correction of doubts is
Mm.
perfect. I can
Yeah,
say that.
yes, yes. Thank you. Thanks
And
for
thank
that.
you for
Yeah.
it.
Yeah, if you guys want about since you guys are new and you are worrying about the level of teachings by us, along with you, there are some guys from the batch 5 also. They can, if willing, they can ask, you can ask them and they can answer their experiences, right? So if you're from batch 5, you can share whatever you are feeling about is it helpful or do you have any concerns? You can proceed with that.
Yeah, like I have been attending the classes even with the Manidhar.
Yeah.
So they very friendly. Like if you ask a number of times, they be clearing it as much as you ask them, they be clearing the doubts. That's the best part. And with reference to FE, with the handbook, they teach perfectly. I can say that.
Thank you, Mohammed. And yep. So that's the thing. And I will proceed further. We'll see what you can grab from the session. So here you can see the screen. I hope the screen is visible, right?
Yes.
Yeah. So we have this. So you guys tell me, is this FE exam? Is it open book test or you did, Saida, you're responding, that's great. So some of you, yeah, who did not attend the exam. So I hope you guys know something about FE exam. Can you guys tell me what are the things you know about it?
Like it's an open book, like you can get the soft copy for the reference handbook. That's it.
Yes.
You
So
cannot, and you can bring the calculator with you.
it's an open book, and the open book is the soft copy, and
Mm-hmm.
you are allowed with calculator. So is it
Right.
scientific calculator or something
Calculator.
else?
Scientific
So
calculator.
it's basically scientific calculator. And coming to the fact, it is an open book test. So is it 100% open book test or it varies with the exam and the date of schedule?
It's 100%.
No, the fact is that it's not 100%. It's around 70 to 80% of open book test. There can be some questions. There were some questions which were out of the handbook, but they are from syllabus, right? The handbook, they have mentioned officially what is there in the syllabus. So if you guys see, I just share you the syllabus right now. So this is syllabus that you can see from the handbook 10.5. I just extracted the pages out of it. For the civil case, there are plenty of subjects. How many subjects we have?
I guess 11.
And
14.
yes, we
14.
have around 14 subjects. And total marks?
110.
Yeah, perfect. So we have 110 marks for that. And out of these 14 subjects, you can see all the 14 subjects are mentioned here, like geotechnical engineering, transportation, structural engineering, water resources, so on. So you can go through them. And the fact is that there are subjects in the handbook, like you can see, if you see the fluid mechanics, I'll show you an example how the fluid mechanics works. Yep, here it is. The syllabus for fluid mechanics for the civil engineers is it's flow measurement, fluid properties, fluid statics, energy, impulse, and momentum. These are the basic things that must be known for civil engineers, and that's why the syllabus is very limited. for the case of civil engineering. And when you see the mechanical engineering in the same handbook, you can see the syllabus is a bit vast. So can you guys answer to my question, just the doubt? Is the handbook that is open to you, will it be same for all the streams like civil, chemical, mechanical, or it will be different?
Same.
It's different.
No, it's same. The PDF that will be open, it will be same for all the streams. So,
Yes, it will
and
be the same.
it is same.
Yes.
It is same, and when you open the fluid mechanics handbook, suppose this is a PDF which you see during the exam, and when you go for handbook there, sorry, fluid mechanics. So I can key this we call them as keywords, which means that to go to a particular topic very easily, you can just search the topic, you will get there. So this fluid mechanics here, there are plenty of things like manometer, barometer, fluid pressure, so on so, and then when they go behind, they go further like Reynolds number, fluid flow characterization, and then the types of flows, different turbulent, laminar, transitional flows, etc., etc. Out of all the pages that are available for fluid mechanics, suppose there are 25 pages. These 25 pages are meant for all the streams together. It's not exclusively for civil engineering. So we can say we need not blindly just follow the entire handbook. So we must go with the priority basis. The first priority is syllabus. You first see what is their syllabus exclusively for civil engineers, and then go for the handbook, right? So if you see my hand, if our notes, these are our efforts we have did, we have split the syllabus like this, whatever the content is there. In the handbook, there are around 12 topics in the handbook for fluid mechanics. Out of that, we have separated the topics which are needed only for civil engineering, and we have nullified the topics which are there for mechanical engineers. So doesn't it help you easily to wipe out the things in handbook so that the length of the handbook just reduces and your brain feels easier to prepare and recall the subjects? And yes, everything is there. I have explained you whatever I said in the words that FE handbook provided during exam is common for all. Fluid mechanics in handbook is for both civil and mechanical. We civil engineers need to only limited topics, and even in the standard books also they have the limited topics. So this kind of suggestions, and if you see our notes, we have did lot of work for units conversion, as Madam Saida asked. There are plenty of examples here, and you can see there are some memory tips, danger tips, where we can make the mistake at the time of exam. If you get some question related to the units, there can be options like acceleration due to gravity. They can be meter per second square, and other option can be meter square per second. So we may get confused in the hurry, or with the overconfidence we may put this as the unit for acceleration. But there are two things in the entire syllabus which looks alike. So we have piled up all the things. You can see the efforts we have did, not only regarding the marks to obtain in the FE exam, we have correlated the content with the actual. Suppose this is an example for capillarity, why the water has been transferred from the roots to the leaves without use of any electricity or any pump or so on. So this is all because of capillarity. You can see why the towel gets wet, the water comes up, or the kerosene lamp, etc. So yeah, you need not to worry about the content we teach, and we can proudly say we are doing the best, or doing the best among all the top institutes that are available in the market. Yep, you can see, always recall the expected range of the answers. We can get answer conventionally for any kind, irrelevant to the subject I am saying. There are two ways of getting the answer. The first way is conventional. So go straight to the formula in the handbook, or go back to the memory and pick up the formula and feed the data, you'll get the answer. And the second thing is, obviously, this is the most followed thing in the competitive exams, like eliminating the options. To eliminate the options, we have many tips like choose the sign, whether it is minus or plus, or choose a range of answer, whether my answer lies between 3 to 4 or 300 to 400. there are some possible ways to pick up the possible practical range of answers. And the third way is through the possible units. If they ask specific gravity, then there is specific gravity doesn't have any units. So you can pick up one of the option which has no units. So such kind of quick answering the questions will be guiding you in that way also. So that's the thing. And coming back to the syllabus, so I'm recalling for the batch 6 guys that I will be taking the subjects. Number 1, that is statics, and then dynamics, materials, mechanics of materials, and then structural engineering, and then I'll go for fluid mechanics. So where is fluid mechanics here? Yep, here. So for the batch 6, that is a new batch. I'm about to start the subject materials, which will help you to get into the civil engineering field. If you are away from the theoretical knowledge, you might be working in some other field or even in the civil engineering field. So I'll just start the subject with materials, so it will be good transition for you to catch up the other subjects. Yep. And coming to the materials, you can see this has about 5 to 8 marks of weightage. So out of this 5 to 8, you can expect the on average the 6 marks. So coming to the 6 marks, we have the mixed design of concrete and asphalt, and then the test methods and specifications of metals, concrete, aggregates, asphalt, and wood. They have basically emphasized 1, 2, 3, 4, 5. So this is all about the syllabus. So let me show this PDF, the materials prepared by me and the team will be shared to you right at the beginning so that you can check it soon after every class. And yes, when I go into this topic, materials, so you guys tell me, what are the different materials you guys see in day-to-day life in civil engineering? Name them.
Asphalt, concrete, wood,
Okay, asphalt
Cement.
is
steel,
Soil, aggregate.
asphalt is
Timber.
fine. Concrete. Someone said wood, and someone said timber, and yes, please. Steel.
Aggregates.
Perfect. Aggregates.
Soil.
Yes, please. What do you say?
Admixtures.
Perfect. Admixtures. Okay. And
soil,
soil. Is it soil, or you mean to say something else? Something, a kind of soil. What soil it is? Excuse me. Yeah. Someone said a pretty good thing, that is admixtures, and then someone said soil. Yeah. You can proceed. Perfect. Glass is also a construction material. And then
Stone.
aluminium,
aluminium.
UPVCs.
Perfect. There are UPVC windows. And
Sanitaries. Sanitary wares.
yeah, sanitary ware, they are not this construction material. They are made of what are they made of?
PVC,
Yeah, sanitary ware may be made of some China clay. There are different materials we are used. Ceramics,
Gypsum.
yeah. Gypsum is also a construction material. Actually, gypsum is a secondary material offered to, to cover the joints between the primary materials like aluminum panels, so and so. Even we can do gypsum false ceiling. Yeah, gypsum is a material, yes. Like this,
Brick.
there are, yeah,
Bricks.
perfect. That's a pretty basic answer we are expecting. The brakes, and then,
Drywalls. Cardboards.
Stone.
yeah,
Stones.
yes, very good. Stones are also construction materials. May not be now to them. So where were stones used in your day-to-day life?
in the form of aggregates.
Yeah, stones, they can be converted to aggregates. I agree. This is right. So
Asphalt.
yeah, stones after converting into aggregates, they are used in asphalt. That's fine. So can't we use stones directly as it is?
You can use the stones in the
Earth
soil
fill.
for the support, soil support.
Okay, fine. Soil support. So which indirectly you are saying,
Stones used for
For
embankments.
embankments,
yes, you're almost near. Embankments. So which we call them as random rubble masonry. The rubbles are nothing but stone. And if you do some masonry work with stone, we call them as random rubble masonry. It does different purposes. They can be used as the boundary walls for separation. They can be used for retaining the soil, as you said, as a supporting structure to the soil, etc. Yep, there are. Did we miss any other something important material? Just think of it. Asphalt, concrete, wood, timber, steel, so on, so on, so yeah. So coming to the most important thing, what is asphalt? Where do we use asphalt? Roads. Yes, they are used in roads. Coming to the concrete, it's used in almost everywhere, right?
Yes.
It is used for buildings, for any kind of RCC works, PCC works, or yep. What is RCC?
Reinforced cement concrete.
Reinforced cement concrete.
Okay, good. And what is PCC?
Precast as
Portland.
precast cement concrete.
Plain
Yes.
cement concrete.
Yes, it's plain cement concrete. Someone said precast. Yeah, that is also kind of concrete we use with the help of steel under compression. Am I right? In the precast concretes, this session is the general session. I will try to just recall all the things which we know till now. So what do we do why do we do precasting in concrete?
While construction of the bridges,
Improve the strength of the cement.
Improves the strength. That's the main purpose. Pretty good. So how does precast improve the strength?
By
So
applying the pressure.
yeah, by applying pressure. Pretty right answer. So the madam said right. So when we know there are some beams, simply supported beams or any kind of beams, when we apply some load, and you guys know we'll use the tension bar here. Am I right? Should I use tension at the top or bottom?
Top.
In the
Bottom.
RCC. Yeah. So anyone else? Is it right? In this case, in a
Yeah.
simply supported beam, when the load is applied, so one of our friends said that the tensile bar, it must be at bottom. Why? Why it should be at bottom?
Because it expands down and
Almost
compresses
near.
on top.
Yes, perfect. You are right. So when we apply some load, the deformation shape will be kind of like this. So it will be something like this. We call this profile as sagging. And because of that, the top fibers, they will be under compression, because you can see, because of bending, this member has elongated to some extent. So this will be under tension. So because of that, we have given steel. Why? Because the concrete has some weakness. What is that weakness of concrete?
weak in tension.
Yes, perfect.
Weak in
Concrete is weak in tension. That's why we in the RCC, we take the help of our friend, that is reinforcement steel. So we place him where we want him. We want him at the location where we have the weakness. We have the weakness at the tension side. That's why we placed it, the reinforcement steel at the bottom. You are right. Now, if the loads are very much increase further and further, so even our friend reinforcement steel can't help to take the load. Then what we do, we give some strength to the reinforcement. Like the Iron Man wear his suit, will give some extra support to through this guy. So what we do, we'll try to pull this guy now. Since steel is it has some elasticity, we'll try to pull him, assume the steel as a elastic, a kind of rubber, and pull him and tight him here and tight at the ends. Now, this rubber band or the steel, to some extent, is a rubber band. It will try to regain its position. With the effect of so, it will try to compress this here. So when you try to compress, so it will be again the tension will be nullified with some compressive force, which is developed due to some elasticity of the steel. So this is all about precast. I just recalled you, and yeah, someone said the cement also, right? So what is cement and how it is different from concrete?
Cement is a binding material in the concrete.
Wow, that's a pretty right answer. Perfect answer. This is cement is the binding material used in concrete. So did we do is it only used in concrete as a binding material? We use cement in some other places. Can you
Mortars.
guess? Perfect. Mortar. Yeah. Other than the madam who answered right now. So what is difference between concrete and mortar? You guys might have heard it in day-to-day life.
Mortar is more like a binding agent
Mm-hmm.
between the concrete or the bricks that is for holding the
One of your
structures.
answer is right. Mortar is used in bricks as a jointing mortar, as a jointing material between layers of bricks. But we cannot use concrete in bricks. So you can see the concrete is made of cement plus
Aggregates.
perfect aggregates,
And sand.
sand,
Water.
water, perfect.
Sometimes
Madam,
admixtures also.
yes, perfect admixtures. So madam said sand, one of the madams, but I did not consider writing it here. Why I did so?
Because that is already included in aggregate.
Perfect. So aggregates is again of two types. Can you guys name it? Basically two types.
Fine and
Coarse
coarse aggregate.
aggregate and fine aggregate.
Yeah, coarse aggregates and fine aggregates. So out of this, one is called sand. Which one is sand?
Fine aggregate.
Fine.
Fine
Yeah.
aggregate.
Fine aggregated sand. Pretty good. You guys are pretty good with the basics. Then it is easy for us to crack FE. This level of basics is more than enough actually. Now, I'll ask one of you guys said the construction material as soil. What is the sand versus soil? What are the differences?
Cohesion
Sand,
property.
Yeah, what is it? What did you say?
Cohesion property.
Cohesion properties. Okay. I can't
also
say in,
sand can be considered as a fine material when compared to the
yes. Yes. So you are right. There is some technical term for this. So the sand has some defined range of aggregates. We call this as it has some definite gradation. So if you study the geotechnical engineering, there is some gradation like 2 microns to 75 microns. We call them as fine
4.75.
aggregates, so and so. So if a particular soil is graded from defined size to size.
4.75.
Yeah, 4.75. Even I myself did not recall it because I'm not teaching those subjects, but you are right. I can remember that. It involves the numerical 4.75. And the soil it's just a raw thing. So whatever naturally you find on the earth during the construction while the foundation, you may get different types of soils. Whatever that are available in the raw
According to
form,
the SBCs,
according to the
SBC,
yes, according to the SBC, you mean saying safe bearing capacity, right?
Soil
So
bearing capacity, I think.
SBC is okay. It is safe bearing. Anyway, you can recheck it. I will also recheck it. It is safe bearing capacity.
No,
Yeah.
I think the classification is based on soil, unified soil classification.
Yeah, you are right. Unified soil classification. You will learn it or you will recall it during the geotechnical class. And you know the soil is again of two types. Like you can say do you guys remember? There can be clay soils,
Silty soil.
silt, sand.
Gravel and sand.
Yeah, gravel and sand. Again, these are type of classifications. It comes regarding the size. Some has more cohesiveness, some has their cohesion less, etc., etc. Yes, that's good. Even in the materials, we have to know something about the aggregates, especially like aggregate impact value. We'll come to know. So, what is aggregate impact value? Aggregate crushing value, and we can call it as something called fineness of aggregates, etc., etc. Water absorption percentage. We'll see them. These are the different things we must learn about aggregates. And coming to the water and admixtures, one of the madam has said admixtures, and the other guy has said admixtures. So, why do we use admixtures in concrete?
To strengthen the concrete.
Okay, the first thing is to strengthen. This is the
As the
right answer.
bonding agent.
Improve
The main
workability.
perfect. Not only just to the sentence, it is right answer, but one of the reasons. Another thing is to improve workability.
And durability also.
Perfect. We can use to improve durability and anything
Least
else.
To
cost
To
saving.
control
decrease
the
the water
setting
Economic.
time of
concentrate.
concrete.
Yeah, what did you say?
Economic.
One by one, please.
To control the setting time of concrete from transportation from batching plants to the sites.
Wow, that's a pretty practical answer. It is being done at the sites to control the setting time, to maintain the concrete, so that it won't set before it reaches the site. To control the setting time, we use the different admixtures. And yeah, even if you're from US states, you guys know at the winters, we need some concrete which are favorable for that condition, which will reduce the freezing and thawing effect. This is something related to the winter climates. Can someone say what is this freezing and thawing that happens in concrete or even in roads?
Freezing of water
Yeah,
within the
perfect.
soil or the rivers.
Wow, that's a pretty, I really appreciate the answers in this batch. So if when you cast the concrete, this might be the aggregates, coarse aggregates, this might be the cement, and this might be the small aggregates. There are possibilities that there can be spaces between the aggregates, pores, we call them as pores. And when there is summer, there will be vapor developed here, and when it comes to the winter, the vapor gets condensed and it forms the water drops. And these water drops doesn't remain as water drops, they will turn into ice. So you guys know, when the water turns into ice, if I take a 1 liter bottle, 1 liter water bottle, fill it completely, tight it, and place it in the refrigerator, especially in the deep refrigerator. We have one other special session in the refrigerator. You can notice you place it for 2 days. After that, what do you notice? Will the bottle remains of same size or it will bulge?
That will be bulge.
Yeah, it will bulge. So assume that bottle has just a pore, a small pore inside a concrete. So you can think, when this ice tries to bulge, then it tries to apply some stresses on the surrounding concrete, and because of the cracks will develop. Once the crack develops, the corrosion happens to the steel. Again, when the steel corrodes, what happens when the steel corrodes in the concrete? What is the
There
change
will
that
be
occurs?
there will be failure.
Rusting.
Yeah, rusting happens. I agree. Corrosion is kind of rusting. So after rusting, again the steel, if you guys notice it clearly, its size also increases. When its size increases, again it is a multiple, the chain reaction. It also crosses the cracks, and it like step by step the concrete will fail. So to avoid that freezing and thawing, and we purposefully create some bubbles in the concrete. To do so, do we have some admixtures that are related to aluminum powder, so on so? Yeah, this is all about the different admixtures we have talked about. Then you guys have, one of you mentioned wood and other of you get mentioned about timber. What is the difference between these two?
Wood is
Think of
harder
it.
and the
Mhm.
timber
So actually, the wood that is used for engineering purposes, any raw wood which we use for engineering purposes, we call it as timber. After you treating it, there are many treating processes, seasoning it. There are some set of sequences after applying some preventive agents like anti-termite agents, so on so. After that, whatever the material you get ready for using especially in the constructions, we call it as timber. And then coming to the steel, what are different types of steel you have seen? Yeah, you can proceed. Do you know different types of steel? Like you might have seen, definitely.
Yeah.
TMT course.
Yeah,
High
okay.
heel,
Yes, what did you say?
high heel steel bars.
Sorry, some of you has to mute your thing. Okay. Yeah, tell me.
It's high yield steel
Wow.
bars.
Yeah, you are about to say HYSD bars.
Yes. Yeah.
High yield strength deformer bars.
Yes.
Okay, these are different types of bars. Especially what you guys are saying here is reinforcement steel. The steel which are especially meant to help the concrete in reinforcement RCC members. We call them as reinforcement steel. And you guys might have seen some steel when you're climbing the stairs, just to hold your hands to take support from something that is railings, those steel will be having some shiny luster. What are those steels?
Stainless.
Yes, there are stainless steels and there are, mild steel.
Epoxy,
Yes, please.
epoxy coated steels.
Yeah, there are epoxy coated steels and high carbon steels. There are different types of steel, to be frank, based on one composition, that is one element. If the composition is more, it will be one kind of steel, and there is some other composition, especially between the high carbon steel, mild steel, and low carbon steel. The carbon composition varies, and to make the steel stainless, what do we add? Even I forgot, what do we add to make the steel stainless?
Zinc.
Yeah, this is zinc, and there are some other steel like
Galvanized.
galvanizer steel to avoid the corrosion, and even there's something galvalume steels. It is like the upper version of the galvanizer steel, galvalume steel, which is like zinc plus aluminum will be the combination to give much more resistance to corrosion. Yeah, that's the thing about the steel. You will go deeper into deeper. If you go deeper, we study in the subject the properties of steel. What are the different properties of steel? You can guess. You tell me. Every material, even the concrete, steel, or brick, have some definite properties.
Physical properties.
Yes, that is physical properties. I agree. And there are some properties called mechanical properties. And there are again properties like chemical properties. Basically, these are the three different properties we have. Now, the basic question, you can guess what my question is. What is difference between physical and mechanical properties of any material, irrespective of steel or so? What is the thing? So you guys might have been hearing these words, physical property, mechanical property, even in 11th and 12th also. You may remember it, but you might have forgot at the time.
Physical means
Resistance to
the
corrosion.
dimensions, maybe.
Mm-hmm.
And
Dimensions.
Resistance to corrosion is a chemical property.
Okay, I agree with that. Your answer is right. It's not the right answer. It adds up to the answer. Fine, I agree with that.
Behavior is a mechanical property.
Mechanical property is behavior. You are 50% right.
And the way it
Mechanical
works,
is performance.
performance, yes.
Perfect. Performance is also
Yeah.
a mechanical property.
Strength.
And strength. Now I agree. This is our much good answer. Then
Durability.
durability. Is durability mechanical or chemical? Does it depend on the material we used for the long durability, or does it depend on the shape?
I think it's chemical, sorry.
Okay,
It's the
durability.
mechanical properties.
So durability is, now I have the question to myself, is it mechanical or chemical? So we'll check it. You guys, if you are working on laptop and have mobile in the time aside, you can use directly ChatGPT and just type the prompt. Is the durability of a material a physical or mechanical or chemical property? It will say the answer. You can try right now. And so is the dimension only physical property? Any other thing? Dimension is right. I agree. Can I say the color?
Shape.
Is it shape? Is again, it's related to dimension again. Fine. And can I say the density as the physical property? Yes, I know the answer because I am teaching, so I have came to know it is density is physical property. But why it is so is the physical properties are the properties of a material which can be identified by physical inspection, just by seeing without breaking it and checking it under the laboratory. Suppose if I say the dimensions, I need not to break the material. I can use a tape or vernier calipers if it is a small material, and you can check the dimensions. If it is a color, you can with a visual inspection, or if it is a very different color, you can use a color scales, etc. And if it is a shape, obviously eye visual inspection. And density also, you guys know density is mass by volume. And mass, you can weight it by keeping on weighing machine, and the volume you can measure it with the tape, and you can get the values and get the details. So there are plenty of like temperature of a body, you need not to break it, right?
Design, like the ribs they use on the top of the reinforcement.
Okay, so
That will be physical property. Then.
yeah, that is, you're right. You mean the surface smoothness or the smoothness or roughness, they are also physical properties. Very pretty right answer. It's really a deeper answer, but it's a right answer, right? So when you go to the mechanical properties, you guys said it right. The strength, performance, behavior. So
We can
the
also add elasticity.
yes. So behavior is now the elasticity, whether a material is elastic or not. Okay, you are taking the rubber band with your hands, you are doing. But if you take the steel, you have to take it to the lab, you have to connect it in the universal testing machine, apply some loads, and then only you can get the elastic behavior of the steel. You're trying to change its shape, right? Changing the shape or breaking it. If you want to know the strength of the steel, again, you have to keep it in UTM and apply the load till it breaks. Then it will give you the reading at this load, your steel will break. Even if you take the concrete, you'll place it in the compressive testing machine and apply the load. When it start cracking, then the dial gauge will stop and turns back. So the last location of the dial gauge will tells you what is the strength. So the strength, as our friend said, elasticity, ductility, and brittleness, etc. All these are the behavior or the performance which needs the actual testing in the laboratory, or you can, in the general things, say you have to change the shape or you have to break the material. Such properties are mechanical properties. And obviously the name says the chemical properties, which means that chemical composition, whether the steel has high carbon or high manganese or it has high amount of zinc, the compositions, if you talk something about composition, that is chemical properties. So yes, this is the different properties we're gonna study for concrete, we're gonna study for steel as well as for asphalt. And what else there in the syllabus? If you go, yeah, where is the syllabus paper? The concrete, asphalt, and then metals. There are different types of metals. Apart from steel, can you say some other metals?
Copper,
Yeah, perfect. Copper,
Aluminum, brass,
aluminium, brass, yeah,
Cobalt,
cobalt. Then,
manganese.
are you sure?
It's a guess.
It's not a metal. Manganese is a integral part, like a steel has manganese. So it's not the metal ultimately. Is gold metal?
Gold. Yes.
Yeah. Okay.
Zinc, silver, titanium, aluminum.
Yeah. titanium, aluminum. They have said aluminum is a metal, and
Silver,
yes,
bronze.
okay, right. Yep. So these are different types of metals we're gonna see. There are different test methods, like as I said, universal testing machine to measure the tensile strength. For compressive strength, there will be different methods. There will be like softening point test for the asphalt, so on so. So coming to this thing, we should not touch. What is asphalt?
There's a mixture of
Bonding material.
Yeah. Now let's go to the here as the material asphalt. Someone said it is a mixture. It's a pretty right answer. Then it is a mixture. You know, the asphalt as the name, to be very precise, we call it as asphalt concrete. Why we are calling it as asphalt concrete is, it doesn't mean that it's same as our concrete. It is a mixture of, instead of cement, we're gonna use some other binding agent. What is that binding agent? We use,
bituminous.
yeah, asphalt, or we call it as bitumen, or we call it as tar. To be frank, these things have different purposes with slight modifications in the compositions or the process by which they have distillation process, etc. I will tell you clearly what's a major difference. But for the FE case, they use only the word asphalt interchangeably for bitumen also, or with the tar also. So here is a case. So there will be a mixture of asphalt, which you can see the black thing that they will heat it and then apply on the road. We have the aggregates, obviously. The aggregates have again gradation. In this, remember, there is no fine aggregates like sand. They use aggregates of 20 mm or 10 mm. There are different gradations of aggregates they will take, right? And there will be pores inside the asphalt. This is the combination of asphalt. We'll study in deep about them. And anything else we left. We are not going to study about the glass. To be frank, glass is not the actual construction material. There will be a structural member like aluminum frame or UPVC frame, or even the wooden frame. And inside that frame, we'll give the glass. Even if you think there are some frameless buildings, there also, if you see, there are definitely structural support like stainless steel hinges or stainless steel, what we call stamps, that will be holding it from behind. So these are not primary structural, construction materials. Even if you see something like sanitary ware, we are not going to study about this. We're going to study only the things that are there in here, like metals, concrete, aggregates, and asphalts. And yes, coming to the, where's the notes? Yeah, here is the notes. I have started the notes with properties of steel, like what is mechanical property. Here I have given the difference between the physical and mechanical, and then I have helped you guys in the FE handbook. Here there are different pages. The pages are same even in the 10.5 also. So here these are the pages I have marked cross so that you need not to refer them. Only the things in the green color are the things related to handbook. Now when I go to the handbook within the pages 119 or so and so, which I mentioned there, what are the things that we have in syllabus are not there in the handbook, especially if I type asphalt. So it is there mentioned in the syllabus of civil engineering, and there is no other content given in the handbook. So, but you can see we have collected with because we don't want to take the risk, and you guys should not lose even 1 mark. So we have did lot of efforts, and we have constructed a precise each and every detail about the asphalt. What is asphalt? What is the specifications of asphalt? Test methods and physical and mechanical properties and practice questions of asphalt. You can see, yeah, I made it like a flow chart so that it will be easy for you to catch. And yeah, I have given the details about it. It is a composite material made of asphaltic binder. And if it is a binder, what is asphalt binder? It is like viscous petroleum byproduct. It acts as a glue to hold the mixture together. It is also known as bitumen. And again, if it is a bitumen or a asphalt, what are different types of bitumens or asphalts? Again, I have given you so and so data. So if you get, it is since asphalt is not there in the handbook, it is a game of your memory. And again, in the game of your memory, I have highlighted the things because I have given plenty of data so that I will be on safe side. You guys cannot say you did not teach me. But it's not done with that. I have to help you which topics are important so that you can, what I can say, you can cut short this content. So for that, I have highlighted the things which you can just remember and just leave aside all the blah 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 explanation, the lengthy, uh, technical explanations are not needed. So for that, I did so. I collected some practical questions so that you can see what kind of questions you can get from there regarding the asphalt. Even there are some contents like the mixed design of concrete. They said concrete in the content, but if you go to the handbook, if you say concrete, you'll not get any content. Like here, they have talked about the reinforced concrete much, but not the basic concrete, how do we design them, etc. So for that also, we have made collected all the resources, the previous papers, etc. And then we framed the examples here. So I am assuring you, if you follow our notes, this is a notes for material. You can see how colorful and how the efforts are seen. You can see the notes for this thing, what we call fluid mechanics. So I am just trying to convey how good or how efforts we are taking. If you take the structural engineering notes, you can see we have made the explanation through different types of flowcharts. I hope Madam Sayada is also saying this. So you can nowhere see this content. I'm pretty sure if you see my notes, nowhere the well-detailed notes is available in the market. The efforts that are put here, you can go through this PDF if you want. I can share you, the team will share you. So that is all about it. I should not say more about our team. The results will say if you attend for few more live classes, you can take your decision. Thank you all. That's it for today's session.
Thank you.
Thank you.
Yep. Thank you.